Hey everybody, in this lesson we're going to talk about naming hydrates, covalents, and acids. Now, again, just like previous lesson, there's different strategies with naming each of these. So first of all, we're going to talk about what is a hydrate. Well, hydrates are ionic compounds with H2O attached to them. So even when dry. So for example, if you ever had table salt and table salt gets exposed to moisture, it will start to clump, and that's because water molecules have attached to that salt crystals and caused the clump. So that is what's going on. So whenever a ionic compound is like um, come across water molecules such as moisture, it will attach to those ionic compounds. So then, how do we name these compounds that have water molecules attached to it? Well, no H2O ionic are called anhydrous. So whenever you see the word anhydrous, it means no water molecules attached to it. Okay. So for example, if you have sodium chloride anhydrous, it means it's just sodium chloride, no water molecules attached. All right. So how do we name them? Well, the ionic compound part is the same. We just add the number of H2O at the end as something hydrate. Now, based on the number of water molecules there are, we will add that prefix into it. So here's a list of prefixes based on the number of water molecules. If there's 1 water molecule, it will be monohydrate. 4 water molecules will be tetrahydrate. 8 water molecules, for example, will be octahydrate. Okay? So let's take a look at our first example. If we look at this one right here, we'll see it's sodium chloride pentahydrate. Penta is 5. So there's 5 water molecules. So how do we write its chemical formula? Well, to write its chemical formula, I actually have to add one more thing here. We write ionic formula plus a dot, number of it plus H2O. So what does that look like? Well, if you look at sodium chloride pentahydrate, we know sodium chloride is NaCl. So now we add a dot here, and we write penta, which is 5, H2O. And what this tells us, it's sodium chloride with 5 water molecules attached to it. So that's sodium chloride pentahydrate. Let's look at our next example. Iron 3 sulfide. So iron 3 sulfide, well, this one we're going to find out what the subscripts will be, because we have iron plus 3, sulfur is minus 2. If you do all the math, find LCM, you should get Fe2S3. Now it's hexahydrate. Hexahydrate means 6, so it's 6H2O. The last one here is zinc acetate. Now zinc is plus 2. Acetate is a polyatomic ion. It's CH3COO minus 1. So that means we need 2 acetates to make them equal. So we have Zn bracket CH3COO 2 dihydrate. So we have 2H2O. Okay. So how do we write and do the opposite of it, which is writing the name of these hydrates? Well, to write the names, it's same as before, but you add, so this is where I should say add the number of H2O as this hydrate at the end. Okay, so let's take a look at this first example here. In this example here, we have iron bromide. Now, which iron is this? Because it's multivalent. Well, this is bromine And bromine has a -1 charge and there's 3 bromines. In this case, because there's 3 bromines, right? So because we have Br, each Br is -1, but it's 3 of them. Our total negative charge is -3. That means our iron must all of it take the +3 charge because there's only 1 iron. So this is iron 3 bromide. Okay, how many water molecules? We have 6. That's hexahydrate. Let's look at the next one. This one is sodium, not a multivalent, so don't need Roman numerals. It's sodium. SO4 is right here. It's sulfate. Now I'll spell it with the F, sulfate with an F, because pH in the F way is exactly the same way. It's just one's British, one's American. So sodium sulfate 10 is decahydrate. Okay. The last example here is Al2O3. Al is aluminum, not a multivalent, so don't need Roman numerals. O is oxide. 3H2O is trihydrate. Okay. So that is what we do with regards to hydrates. What happens if we're trying to name covalent compounds now? Well, first of all, what are covalent compounds? These are compounds that are made up of 2 or more nonmetals in a compound, which means there are no metals involved. So because of that, how this works is they instead of transferring electrons, they share electrons. We're going to go into more detail about this in the atomic theory unit. Okay, so what do we do with covalent compounds? How do we name them? Well, what we do with covalent compounds is, the strategy for writing formula is, we have prefixes like the hydrates to tell number of each element. Okay, so what does that mean? Well, we still want to write, so what we have here is we have the symbols for each element, but we also have the subscript, the number, the prefix is our subscript. So let's take a look, okay? So dinitrogen trioxide. Di is 2, which means we have 2 nitrogens, subscript N2. Trioxide, oxygen. How many oxygens? 3. So we have 3 oxygen as a subscript. That's N2O3. Okay, sulfur hexafluoride. What's going on here? How come sulfur has no prefix? Well, it's because whenever the first element is only 1, we don't need to put mono in front of it. We can just leave it as sulfur. So in this case, sulfur is just 1. Hexa is 6, 6 fluorines. 6, SF6. The last one is dihydrogen monoxide. Di is 2. So we have 2 hydrogens. Monoxide, 1 oxygen, H2O. Okay. So we're going to get into more detail about the sulfur, why you don't need to put a prefix in front of it in our next example. Because when we talk about naming covalent compounds, well, what we have here is we keep first element the same, but change second element's ending to "ide." Okay, we use prefix to state number of each element. But lastly, if first element is 1, you don't need mono. Okay. So let's practice this. Okay, so CO2. Now because carbon here is only one, we don't need to put monocarbon. It is just carbon. Okay, so carbon's name doesn't change, it's the first element. The second element is still going to be ide, so this is still oxide. But how many oxides do we have? We have two. So it's actually carbon dioxide. It's what you breathe out. Okay, let's look at the next example. Now this one, this phosphorus here, there's multiple phosphorus, there's two. So now we do need a prefix in front of phosphorus, so it's diphosphorus. How many oxygens? We have three, which is trioxide. The last one here is same, it's dinitrogen. Trioxide in this case. So again, there's three oxygens. To finish up this lesson, we're going to talk about how do we name acids. So there's three categories of how we name acids, okay? So what I'm going to do right now is I'm going to make a table right here. You can make the same table in your paper if you can, okay? And we're going to divide it into three columns. Okay, so three columns. So that's column number one, and we'll make column number two. So why we have three columns is based on what we're dealing with and what kind of acid we're dealing with, okay? So the first category of acid, first of all acids start with the element H. That's what we gotta know. Hydrogen acting as a metal makes something an acid. Okay, acid has hydrogen acting as a metal. Okay, so here's what we have. If nonmetal is a monatomic, so one atom, one type of atom, this is what you do. Start name with hydro. Okay, so hydro will be the front of the name. Number two. So number two. So first of all, start name with hydro. Number two is end nonmetal as ic now. So no longer ide but ic. So for example, HCl. So Cl is monatomic. So because of that, we still keep the hydro. It's hydro chloric, not chloride anymore, acid. Okay, so that's if the nonmetal is monatomic. All right. So our next thing, if nonmetal is polyatomic, and this is where we have different ways. If the polyatomic is ending in 8, okay, if it's an 8 polyatomic, because the polyatomics we deal with are either going to end in 8 or ite, I-T-E or A-T-E. So it ends in 8. The first thing is no need for hydro. So you don't have to put hydro at the front of its name anymore. But number two, you end with ic. So here's an example. If we have H2SO4, H2SO4, SO4 is sulfate. SO4 is sulfate. So we don't need hydro. It's not hydrosulfate. It's going to be sulfuric acid this time. So no more hydro in the front of the thing. Alright. So our last example. Okay, if nonmetal is polyatomic again, but this time the polyatomic ends in ite. It's an ite polyatomic, I-T-E. So again, no need for hydro. But now, end with O-U-S, us. So what does this mean? Well, in this case, if you write, let's say, H2SO3, SO3 is sulfite, so SO3 is sulfite, then this will be, instead of there's no hydro involved, it's sulfuric phosphorus acid. So it ends in us. So what happens here is if it's a monatomic, you keep hydro and you end in ic. If it's polyatomic, if it's 8 polyatomic, you turn into ic, no hydro needed. If it's 8 polyatomic, no hydro is needed, but ends in us now. So let's finish up our last few examples. So HI. HI is, as you can see here, monatomic. So you still need hydro. Well, what's I? It's iodine. So it becomes iodic acid. So hydroiodic acid. Because you need hydro because it's monatomic. Okay, so if you want to write this down, this is monatomic. Hence why, okay? This one is polyatomic. Because PO4 is polyatomic. Now, what kind of polyatomic is this? It is phosphate. It's an 8 polyatomic, which means it should end in ic still. You don't need hydro anymore, so it's phosphoric acid. Okay, it ends in ic. The last one doesn't look like an acid because it doesn't look like it has hydrogen to start with its name. But technically, this chemical actually be written with a hydrogen can be at the front of the name. This can be written as H, CH3COO. We just don't write it that way because this is a way to show the chemical structure of CH3COOH. So in this case, this one will be, well, CH3COO is acetate, polyatomic. So it's polyatomic, it ends in 8, it becomes acetic acid. Acetic acid has a very popular street name. We call this chemical on the street vinegar. So, as always, make sure you keep yourself safe and healthy, and I'll see you soon.